Hello, we're Virtual Integrated Solutions. I'm Matthew Hutchings, project leader, and this is our low voltage model virtual power plant. Basically, if I run through what's going on, we have our motor controller here, which basically controls this DC motor to produce varying wind speeds to act like a wind profile. Essentially, the motor generator set here is effectively a wind turbine, and we're controlling it to behave as one. As we go through the system, the generator outputs three-phase AC, which is then rectified to a DC voltage. This DC voltage obviously is varying because of the output of the generator. The boost converter here, which then takes that varying DC voltage and boosts it to the DC bus voltage of 50 volts. And the next component here is the buck converter. This buck converter reduces that bus voltage from 50 volts down to 12 volts, which is the input to the inverter. This inverter then transforms the 12 volt output 12 volt DC signal to a 230 volt output that you would find in your home, and that's why we're applying a load of loads on it. And we've got our iDock. We've got a lamp which you can switch on. It comes on nicely. You can change your power loads, all sorts of things. Switch your N64 on. Play a little bit of Zelda. Very floats your boat, really. If we come back along the system, we now have this battery storage here. This battery storage is controlled by this bidirectional converter here. The bidirectional converter basically is the main management system, the way of managing the power. What happens is when the wind generation is greater than that of the load requirement, that the bidirectional goes into battery charge mode. This battery then goes into, then takes power from the bus and charges the battery. At the moment, it is currently discharging the battery, so you won't be able to see, it. But you can see as the wind generation starts to pick up, hopefully it'll go to above. Yeah, and now because the wind generation is picked up, the load is that, and it's now starting to charge. And you can see it's charging because the battery voltage is higher than it was before, and it's starting to increase. So yeah, that's the system. We'll wait until it gets back down to discharge. Yeah. So basically now we're just waiting for the wind profile to, well, it's increased, there you go. The variable nature of the wind has decided to increase. So then we'll be obviously charging the battery with more power. Thank you. More voltage. Oh, get out of the way, we've got the lovely Kevin playing a bit of Zelda.